Hey, this is Mark Smith, host of Digital Roughnecks, and I'm here with Thomas Fox, the founder of Highwood Emissions Management. Welcome, Thomas.
Thanks, Mark. Nice to be here.
Now, Thomas and I, full disclosure, do work together. In fact, Thomas helped Clean Connect put together an application for Colorado. We call it the AIM application, Approved Instrument Measurement Method. So we've done some work together. And it was through that I found out that Thomas was working with Veritas and other organizations to come up with a brand new methane intensity standard. So with that, I'll turn over to Thomas. You can kind of give a little backstory about why they decided to tackle this and what the goal of this new standard is.
Thanks, Mark. Yeah, no, that's a great way to kick things off. So I'm going to share some slides just quickly, and then we can kind of proceed into a discussion after that. Thanks for having me. My name is Thomas. I do a lot of technology evaluation at Highwood Emissions Management. I've been working on a few other projects as well. One of those is alongside Gas Technology Institute, GTI, on a new standard for measurement of oil and gas infrastructure. And how to use measurement, all these kind of new innovation that's available to improve our understanding of what emissions really are, and to enable better kind of methane intensity estimates and better disclosure of emissions information. So today I'm here kind of to present on this initiative, which again is being led by GTI. Highwood is just supporting the effort. It's a pretty big initiative and pretty exciting, and we think it's going to have a big impact. So the guiding force here is the fact that we're seeing an emergence in a need to clearly understand and articulate and disclose methane emissions data. We're seeing a big push for responsible gas, or differentiated gas, regulatory reporting of emissions data, and so on and so forth. And in the past, whether it's methane intensity or which is emissions divided by production or throughput, or just emissions, a lot of reporting and quantification of emissions has relied on emissions factors, which are industry averages. And there's been a huge amount of innovation in the last 5 to 10 years in methane detection and quantification technologies that could potentially be used to improve how we estimate and report our methane emissions. And so Veritas is really about building out a methodology for how we understand these new technologies, what they can do, and how their measurements can be incorporated into our understanding of emissions by company. The goal of Veritas is to develop a set of standards, which can be thought of as really a methodology to guide the deployment of technology to acquire the right data for demonstrating methane emissions at a facility scale or company scale, and then how to use those measurements and perform reconciliation with bottom-up inventories to get a better overall estimate of methane emissions or methane intensity. Lots of folks involved. There's a really great group of foundational sponsors, companies primarily in the US who are really excited about this effort and want to see it succeed. GTI, as I said, is the lead on this project. Highwood Emissions Management and SLR are supporting it, and then there's all kinds of other folks involved. There's technical committees for each segment of the supply chain. We're covering 6 segments, and I'll cover that in a second. There's an expert panel with leading academics who are providing comments on the standards as we develop them. There's vendors involved and regulators and companies who are doing demonstration projects and various other stakeholders. So I'm not going to be able to really get into all the details of Veritas today. Obviously, the standard isn't public yet. Some information is public around kind of the high level intentions and what, what we hope to achieve. But at a high level, there's a number of protocols that comprise the standard. The meat and potatoes are really in the measurement and reconciliation protocols. And so this is guidance for what technologies to use and how to deploy them, sample size, and measurement frequency, and detection limits, and all that kind of stuff. Reconciliation is kind of this new idea of if you acquire estimates around emissions in different ways, how do you account for the differences in those estimates? And so we're seeing this in OGMP and now in Veritas, and others are talking about what this looks like. But effectively, it's looking at your bottom-up inventory, and then looking at site level measurements and trying to explain differences between the two. And then we have intensity protocol, which is basically how to calculate methane intensity and account for kind of the uncertainty in that, and use measurement-based approaches to estimate intensity. How to kind of consider methane intensity across the entire supply chain rather than just for one segment, and then an audit and assurance protocol for those who intend to leverage Veritas and to deploy it. And then this is kind of a similar kind of depiction, but it's basically just shows that for each of the 6 segments, we're doing the measurement, reconciliation, and intensity protocols. So there's actually going to be, at this time, we believe, around 21 different documents that comprise this protocol. And the reason that we're doing that is that there's a lot of nuances between the segments in terms of how emissions measurements should be performed and how intensity should be thought about and calculated. So, for example, things look very different for a well site than they do for a transmission line. And so we're trying to account for the entire journey of the natural gas molecule from production, from the wellhead to end use, and even considering LNG as well. Just quickly, gonna kind of go through the measurement and reconciliation protocols. In the measurement protocol, and this is for production, but the general themes are going to be similar and among kind of the different segments. So the first thing is really to identify kind of what measurement technologies exist. Obviously, there's huge diversity in options right now. I think there's well over 100 commercially available methane measurement solutions in existence. Understanding how to apply these different technologies, it depends on considerations around what assets are kind of within scope, and what kind of emissions are expected to come from those assets. And so we have a site categorization process which allows operators to tailor their deployment strategies to the types of assets that they have. So one example would be to categorize sites based on whether they're complex or simple, and the EPA is kind of proposing to do this in their new draft regulations. But an example would be well sites versus more complex tank batteries or compressor stations. And then, establishing expected emissions distributions. We know that expected emissions would vary by basin, vary by production type, vary by the types of facilities that you're looking at. So understanding the expected emissions profiles of the sites are important to understand kind of and predict what technologies are going to be most effectively deployed at them. And then we provide guidance for how to deploy, how to select and deploy the best kind of available solutions, and establish sampling strategies. So measurement frequencies and sample sizes needed in order to kind of narrow in on the right data that's needed for estimating overall methane emissions across all sites within an operator's purview, and then obviously deployment. The reconciliation protocol looks at the data that's been collected during measurement, determines whether there's any data that needs to be removed from the data set, and performs reconciliation. I'll get into the reconciliation in a second here, and applies tests as well. So the reconciliation process consists of one of 3 pathways. The first is, and these are basically, depend on how sensitive the technology is that's being used for measurement. So for systems with sufficiently low minimum detection limits that are able to capture the majority of the emissions that are expected to be emitted from a facility, it'll be basically operators will be able to rely on kind of exclusively the measurement data and not necessarily have to rely on the inventories. For systems with very high detection limits, where most of the measurements are expected to be kind of anomalous events that are not accounted for appropriately in inventories, it'll be an additive exercise where the measurements and the inventories are added together. And then for measurements with intermediate detection limits, which I think for technologies with intermediate detection limits, which I think is the majority of systems, there will be a kind of complex reconciliation process with bottom-up inventories that needs to happen. And this is basically going through measurement data and determining, doing a root cause analysis for any events that occurred to determine what was happening on site and preventing double counting. So you don't want something to appear in both your inventory and your measurements, but you do want to take the best of both worlds. So for something like a blowdown, you would probably rely on the kind of engineering equations of, what was the diameter of the pipe and the pressure of the gas and all of that, and the length of the pipe that was blown down. But for other types of sources, you might opt to rely on measurements. And then finally, a test is performed to determine whether the majority of the measurements came from, or of the kind of final methane intensity or emissions estimate comes from the measurements, because we do want this to be a measurement-based standard. And again, there's a ton of nuance and exceptions in all of this, and not all of it is currently finalized. This is kind of a sneak peek. We're thinking that hoping that the protocols will be released publicly in the fall after demonstration projects are completed and the results are analyzed. A question that we get asked a lot is, where does Veritas fit within the kind of broader ecosystem of voluntary initiatives? As many of you know, there are a lot of options out there for how to basically take credit or commit to emissions reductions as an oil and gas company. Highwood, in May of 2021, we released a report, an overview of emissions reduction initiatives, voluntary emissions reduction initiatives for responsible oil and gas. This report is publicly available on our website, and at the time Veritas didn't exist, and so it's not included in the report. We're currently working on version 2 of the report, which we're hoping to release in either May or June of this year. But effectively, the primary findings from this report are listed here, and kind of one of the biggest ones was to understand the role of measurement and technology in the future of these voluntary initiatives. And the reason for that is that a lot of these initiatives, whether certifications, commitments, guidelines, ESG ratings, and I think there's going to be new categories in the updated version of the report. The vast majority of them don't rely on methane intensity to begin with as kind of the common denominator or the currency for understanding methane emissions. And if they do, the vast majority of them don't rely or require measurement-based methane intensity. And we know from past studies that emissions factors-based inventories tend to underestimate actual emissions. And if everyone's using the same emissions factors, then it doesn't provide a very compelling basis for comparing different companies or different basins or jurisdictions or whatever it is. So where we see Veritas fitting in is as a methodology to improve these voluntary initiatives and improve their capacity to calculate methane intensity and to have more robust measurement-based emissions reporting and disclosure and tracking of progress. So we see this as primarily as a tool for other voluntary initiatives to use. And just as an example, we like to kind of use OGMP as a benchmark because it's a lot of folks are talking about it these days. So in OGMP, you set targets and you establish a phasing plan. You estimate your baseline emissions. You basically need to track your emissions over time and constantly improve and get better and better at performing measurements, and then report the progress that you've made in reducing emissions. For Veritas, you don't have to do any of these things. There's no targets, there's no reporting, there's no tracking. It's really intended to be a methodology that's adapted by other initiatives, by OGMP, by regulators, by anyone who wants better methane data, and wants that methane data to be collected according to a robust standard that is replicable and transparent. Fundamentally, OGMP is really a framework, a reporting framework for setting targets, tracking progress, and reporting emissions. And Veritas is fundamentally a methodology for measurement-based methane intensity, or measurement-based methane emissions and intensity calculations. One primary thing that is similar between them is that they both have a kind of a similar color logo, which is probably just a coincidence. That's it for me. I'll stop sharing. And Mark, I don't know if you have any.
When you talked about the different measurement technologies, your low measurement detection limits, that's low meaning you can find low leak levels, or what does that mean?
Yeah, I mean, when we think about sensitivity of instruments, it can be kind of, tends to be a little bit complex because there's probability of detection. And that probability of detection of any given source can change based on the emission rate of the source, based on the wind speed, based on if there's certain conditions, humidity or temperature, or if the leak is indoors or outdoors, and there's all kinds of factors. So there's a probability of detection that tends to differ by leak size as kind of the primary driver primary kind of independent variable of whether something will be detected. So when we say high detection limit technologies, that means that they're kind of more likely to detect larger emission rates. You can think of, on the spectrum of solutions, aircraft and satellites are further away from the source and tend to have slightly higher or much higher detection limits than something like an OGI camera that's right beside a leak, right, or maybe a drone that's flying really, really close to a source.
Okay, very good. And I like the phrase the entire journey of the molecule. Mm-hmm. Very interesting. So the protocol attempts to have meaning and in process and methodology through that entire journey. Essentially all the way down to the consumer flicking on a light switch, or from the ground to usage. Is that what you're talking about, or how far? Because I did see on one slide scope 1, 2, 3.
Yeah, that's so I don't know that we're doing scope 1, 2, 3. It's just methane.
Yeah.
The idea is to track the molecule until it is used, right? And so all the way to distribution from production. And so we have different groups of technical experts working on each of the segments. So we have experts in production working on those protocols, experts in LNG or storage working in those segments. And then we're at a higher level, we're trying to build a value chain summation protocol that stitches things together. And One Future has actually done something similar. But basically the idea is if you calculate methane intensity in production and calculate methane intensity in gathering and boosting, you can't double count the throughput or the production because it's the same gas. So you have to find a way to add them together if you want to understand the methane intensity as the molecule travels through the entire value chain.
And so then the timeline, you're talking about, having something maybe by fall where it'll be officially released, but alongside of some sort of proof of concept or pilot with one actual operator doing it, or what's the deliverable there?
Yeah, so the protocols are drafted at this time. We currently have 12 operators doing demonstration projects, piloting the standard in various ways. We have representation in each of the segments. So we have at least one operator in each segment piloting, currently doing a demonstration. And so the process is, once those demonstrations are complete, we'll, help look at the data and figure out, if any adjustments need to be made to the protocols before they go out.
And in the draft, but there'll be enough for somebody who's not part of that core team to be able to see what's going on. So if they wanted to pilot it on their own, they could potentially.
I'm not sure. I
Okay.
can't really comment on that. Yeah.
All right. Very good. So where can someone find out more about this when it is somewhat public? Is there a website for Veritas or where will it be published?
Yeah, so GTI, Gas Technology Institute, is leading the charge here. I'm not sure. I'm almost certain that the standards will end up, being held at least initially by GTI and distributed by them. But I'm not sure exactly, where it'll end up. So keep you'll see it in the news. I'm sure it'll be hard to miss when the protocols do become publicly available. I'm not sure if there's going to be a public commenting period or not, or whether that is going to happen internally. But we're definitely on track and excited and getting good feedback, and we think it's going to make a splash when it comes out. So yeah, looking forward to everyone's thoughts when that happens.
All right. Well, thank you for allowing Digital Roughnecks to get a sneak peek of this brand new methane intensity standard. I think it's a step in the right direction. I know that operators we talk to are looking to do actual measurement versus formulas. So this will be a huge step in that direction.
Yeah, thanks for the opportunity to share. We're really excited and can't wait to see what we can do with this new protocol. So
very good.